Hey, Maramba, your audio. Okay, now it's fine. All right, you are now back. Let's continue with our question, wherein we are given variable x equal to 9 and y, which is equal to negative 11. It's equal to negative 11. So the question says use commutative properties to obtain the solution. Why do we say properties here? Because we are having addition and what? And multiplication. So let's apply those and see what answer we will get. We start by the left hand side of this, which in this case is x and y. So x is given as 9 and y is given as what? As negative 11. So when we add these two values, what do we obtain? When we add these two values, what do we obtain?
Negative 2.
Yes, we are going to obtain the answer of negative 2. Okay, let me lock the screen so that you can see the whiteboard, all of you. Do you all see the whiteboard?
Yes.
Okay. Wonderful. So we are going to obtain the answer of negative 2 in this case.
Yes.
Yes, but you can see we have done on the left hand side. Let's do the same on the right hand side. So wherein we are now adding y plus x, where we are given that y is negative 11 and then x is equal to 9. So negative 11 plus 9 is going to give us an answer, which is exactly the same as this, because we are applying the property which is already proven, the addition property under commutative in this case. So it's going to give you the same answer. So we also have to test the same principle on the second operator, which is multiplication in this case. So we start by multiplying x and y, wherein x is given by 9 and then y is given by negative 11. What is 9 multiplied by negative 11?
Negative 99.
Negative 99. Of which it must be the same as multiplying y and x, which in this case is going to be negative 11 multiplied by 9. Yes.
What happens if the answer is not the same?
For real number, there's no way that you're going to get the different answers in this case. But for complex number, I can tell you, you're going to get different answers for these properties.
Okay.
Yeah. You are going to get different answers for complex number. I'll remind you when we are applying this on questions, because this, you can see this is just to show that these properties, they work. But we are going to have specific questions where you will need to apply these properties. You will see, I will remind you when we do those specific questions where we apply the same properties, and you're going to apply them a lot. That I can promise you. Okay, let me give you a question to do. So I'm just wrapping the Z there and wrapping the associative, and then put the commutative. So I want you to tell me the answer you obtain when x is equal to 2 and y is equal to -3. So when using the commutative property to obtain the solution. So what do you get as the answers for this? Can I give you 2 minutes to attend to that question?
Sir?
Yes.
Oh, I understand. No, I got what you said. I got it.
All right. All right, tell me the answer you obtained when adding these two.
-1.
You obtain -1, of which is the same when you add as x plus y. And then on the other side, you will be adding y and x. You must obtain the same answer. And then for multiplication, we're going to get -6, right?
Yes.
Yes.
Which you're going to obtain by multiplying 2 and -3, and which is the same as multiplying -3 and 2. So the same. Those are the properties which you must take note of. So now let's go to our last part of the lesson, which is about perfect square. This is not going to take time because it's a very, very simple topic, which I believe you may have read about the topic before. So now, very first thing which you must know about the topic is about what do we know about this, which is called perfect square. And even the word it renounces about what it means, perfect square. So now, perfect square in this case, it's simply a number. This is a number that can be expressed as the square of the number from the same number system. Simple as this. This is the definition for the perfect square. So perfect square is a number that can be expressed as the square of the number from the same number system. So let's give an example. If we are talking about a square of 3, perfect square, let me say perfect square of 3. So perfect square of 3 is going to be 3 to the power of 3, which is 3 to the power of 2, which is the same as 3 multiplied by 3. And we know the perfect square of 3 is what? It's 9. Are we all together?
Yes.
The perfect square of 3 is 9, because you will need to multiply 3 with 3 to obtain the perfect square. So let me give you another example. So the example of a perfect square is 2. Let's say we want perfect square of 2. Perfect square of 2. Can any one of you tell me what would be the perfect square of 2?
4.
Oh,
4, as simple as this. So it's 2 to the power 2, which is the same as 2 multiplied by 2, and this is going to give you the answer of what? Of 4. Do you see this is simple?
yes.
Yeah.
All right, let me give you some difficult questions with regard to this. Let's say we are given these kind of numbers. So we need to cycle a number in each row that is not a perfect square. Perfect square. So we need to cycle those numbers which are not perfect square. So let me give you the numbers. We have 3, 25, 81, 100, 121, 4, 12, 9, 144, 86, 1, 16, 27, 49, and then the last one is 64. So let's identify those numbers which are not perfect square. I believe by now you know what we mean by a perfect square. So is 3 a perfect square?
So wait, let me first copy the instruction.
Sorry?
Let me first copy the instruction.
All right, yes, copy everything. So cycle the number in each row that is not a perfect square. And then we're given 3, 25, 81, 100, 121. Then on the second row, we're given 4, 12, 9, 144, 36. And then on the last row, we're given 1, 16, 27, 49, and 64. So we want to identify those which are not perfect square.
Sir,
Yes.
is that a 1 next to 16?
Yes, this is the one. The first one is 1.
And how do we know that it's a perfect square?
We know it's a perfect square if when you square that number is going to be if we are saying 9 is a perfect square, for example. Okay, let me use different number. Let's say 36. If we are saying 36 is a perfect square, it means that there must be a number of which that number, when you is having a square of 2, is going to give you 32. So now, for example, 6 to the power of 2. What is 6 to the power of 2?
6 to the power of 2, it's 36.
It's 36. So it means 36 is a perfect square of what? Of 6. Do you see
Of
that?
6.
Yes. And now, let me
Yes.
give you the second example. Let's say we have a 20. Can we write a number with a square that will give us 20? Is there a number which, when we square, is going to give us a 20?
Yes, 10.
What is 10 to the power 2?
10 to the power of 2 is
100.
wait, yes, it's wait.
Alright.
Adiba, what if last year? No, it's not there.
Is 20 a perfect square or not?
No, it's not.
It's not, because you can't find any number which, when you square, you're going to get 20. Are we all together?
Yes.
Yes.
All right, now let's identify those which are not perfect square. Let's start with the first one. Is 3 a perfect square?
No.
No.
It's not, because there is no number which you can find of which, when you square, you're going to obtain a 3. So therefore, let's cycle a 3. Is 25 a perfect square?
Yes.
Why do we say it's a perfect square?
Because 5 to the power 2 gives us 25.
Very true. So it means you are now getting it right. Is 81 a perfect square?
Yes.
Yes.
Why is a perfect square?
No, it's not. Eh?
It
Why
is.
not?
Do we need?
3 to the power. No, does it need to be
No,
to the power 2
Yes.
only?
Oh,
Yeah, it must have a exponent of 2 only.
it's
Okay.
not.
It's not a perfect square.
Yes,
Yeah.
it's not.
Why do you say it's not perfect square?
Because it's to the power 4, not 2.
Power 4.
9 to the power of 2 is what?
9 to the power of what?
Of 2.
Yeah,
It's 81.
it is.
Yes. So this is a perfect square, eh? And
Yes.
100 is 100 perfect square, a perfect square.
No.
No.
All right. Why do you say it's not a perfect square?
Because
It's a perfect square.
It's a perfect square. Because 10 to the power 2 is what?
Oh, yeah.
oh yes.
Yes. And then 121, is it a perfect square?
Yes.
Why do you say it's a perfect square?
Because 11 to the power of 2 gives us 121.
Very true. And then 4, is it a perfect square?
Yes.
It's not a perfect square.
Yes. 4 is a perfect square because 2 to the power 2 is 4, right?
Yes.
Mm.
And then 12, is it a perfect square?
No.
Why 12 is not a perfect square?
Because it's 2 to the power 2 times 3.
Exactly. There's no number which when you square is going to give us 12. Are we all together?
Yes.
And then 9, is 9 a perfect square?
Yes.
It is, because 3 to the power 2 is what? It's 9, eh?
9.
Yes.
And 144, is it a perfect square?
No.
No.
Let's test 12 to the power 2. What is 12 to the power 2?
144.
44.
See? So you be careful there. And then 36, is it a perfect square or not?
It is.
It is. Why do you say it's a perfect square?
Because 6 to the power of 2 gives us 36.
Very true. You're going to get 36 if you have 6 to the power 2. And 1, is it a perfect square?
No.
No.
What is 1 to the power 2?
1 to the power 2. It's 1.
You see, this is a perfect square. And then 16, is it a perfect square?
Mm,
Yes. No, it's not.
What is 4 to the power 2?
lol.
It is. No?
Our calculators are giving us wrong things.
No, I'm going to simplify this for you after I finish. So now, 27, is it a perfect square?
No.
All right, because there's no number which when you square is going to give you 27, right? And
Yes.
49, is it a perfect square?
Yes.
Yes.
It is, because 7 to the power 2 is 49. And then the last one, is it a perfect square?
No.
Test 8 to the power 2. It is, né? All right. Okay, I know that approach I've explained to you is demanding. So I'm now going to explain a very, very simple process for you to get to this answer. So instead of finding a number, let's get back here. Eh? So instead of finding a number, which when you square is going to give you 36, you are now starting from this that you're given there, a perfect square. A number which you assume is a perfect square or not, you then put a root under that number. So what is root of 36? It must give you this 6. What is the root of 36?
6.
Is 6. Therefore, if you are getting a number without comma, then you must know 36 is what? It's a perfect square. Are we all together?
Yes.
Let's go back to this. Root of 3. What is the root of 3?
It's 3.
I found what you are saying.
And then you do the SD and then it gives you 1 comma what.
Yes. So that's why we say this is not what? A perfect square. Why? Because we're getting numbers with what? With commas. Are we all together?
Yes.
And then what is the root of 25?
5.
You see?
5.
That's why we say this is a perfect square, because we're getting numbers without commas. You can test all of them. Root of 81 is what?
A 9.
A 9, which is not even comma. Even 100, you're going to get 10. 121, you're going to get 11. Root of 4, you are going to get 2. What is the root of 12?
2.
It's 2. No, it's 3.5.
4, 6, 4, and the
6, 4,
others.
1. Yes.
Yeah, because you're having commas, it means this is not what? Perfect square. Are we all together?
Yes.
Yes.
And then again, you can test for these other ones. I can assure you that all these other ones, if you put them under root, they are going to give you numbers without commas. Are we all together with regard to perfect square?
Yes.
If you have any question, ask me before I give you the homework for the day. You can ask me if you have any question. So, you guys, you don't have any question. I'm gonna send you a homework. I'm gonna send you a homework immediately after a class for our call, so that you can see how we answer the questions for perfect square. Otherwise, for today, let's end here. Okay, Adish is here, ne? Adish?
Yes.
Yeah, can you please ask God to come so that we start with our lessons? So she can use the same link to log in. So I'm now going to end this one and then log in again using the same link so that it does not record on the same link. But let her use the same link to log into the meeting.
Okay.
Okay, with let's end here for this class. Goodbye, everyone.
Bye.